I am Dr. W. Gunole from Kamlanenu Mahavidyalaya, Nagpur. Today we are going to discuss the fats and oil. As we know, fats and oil is the essential part out of three important part of our food, and other two are the carbohydrate and the protein. So oil and fats are very important and important source of the food. And as we know that here in today's presentation we are going to see the what is the natural fat, and after that what is the difference between oil and fats. As we know, fat is a solid and the oil is a liquid, and what is the chemical difference, that also we are going to discuss in today's presentation. And after that, composition of the oil and fats, and the what are the different types of fatty acids and the composition, and after that the that is the types of simple and mixed oil and fats that we are going to see. And after that, the analysis of fat and oil, and three methods are there. One is the saponification value, acid value, and the last is the iodine value. All these three methods we are going to discuss in today's presentation. So today's topic is fats and oil, and as we know, fats and oil are the triglyceride, and here in the introduction, fats and oil are widely distributed in the nature, both in animal and plant kingdom. In animal, they are present under the skin and in muscles, but in the plant, they are mainly found in the seeds. Some important example of fats are butter, lard, tallow, beef, etc. And in case of the vegetable oils, that is in case of oil, groundnut oil, cottonseed oil, olive oil, palm oil, coconut oil, sunflower oil, soybean oil, linseed oil, sesame oil are the important example of vegetable oils. And as we know, fats and oils are of one of the important constituent of our food. Other two components are carbohydrate and protein. And third, this is the one, fats and oil is the important or major constituent. Fats and oil act as a energy reservoir for animal. In human being, only the few 100 grams of glycogen, that is carbohydrate, can be stored, which can supply the body energy need for about 12 to 18 hours. In contrast, large amount of fats can be stored, which can supply the body energy needs for about 8 weeks. And beside this, oil and fats act as a raw material for number of industries, and industries like soap, paint, varnishes, and also vanaspati ghee. So these are some some what is meant by fats and oil. And now natural fat is also there. So what is natural fats? So we can say that fat which is obtained from animal sources such as butter, that is milk of cow and buffaloes, lard from the hogs, and tallow from the sheep, goat, etc. are called natural fats. This name is given to differentiate these fats from those fats which are obtained by the hydrogenation of oil. And two important oils are there. One is edible and non-edible oil. So what is edible and what is non-edible oil? So we can say that non-edible oil is also known as industrial oil. Oil like groundnut oil, sunflower oil, soybean oil, mustard oil, olive oil, sesame oil are used for cooking purposes, and therefore they are known as edible oil. While in case of the oil like cottonseed oil, linseed oil, and castor seed oil or moa oil, which are used in the soap, paint, varnishes, lacquer industries, and these are known as non-edible oil, also known as industrial oil. So two types of oils are there: edible, which are used for the cooking purpose, and which are used in the industry, they are known as non-edible oil. And as we know, on the basis of iodine value, oil can be of the three different types, that is drying, semi-drying, and non-drying oils. And industrial oil may include essential oil or mineral oil. Essential oil such as rose oil, jasmine oil, lavender oil, eucalyptus oil, peppermint oil, these oils are volatile oil isolated from the plant. And essential oil may be hydrocarbon, alcohol, aldehyde, ketone, ester, but not ester, of glycerol. For example, peppermint oil contain menthol and alcohol, and it is the chief constituent. Essential oils are mainly used in the perfume, cosmetics and pharmaceutical products. So here these mineral oils cannot be saponified. They are called oil simply because of their physical appearance. They are non-edible and are mainly used as a fuel. So there are two: industrial oil or mineral oils. And here, so these are the two types of oil, and example of edible and non-edible oils. And now we are going to see what is the composition of oil fats, also known as triglyceride. As we know, fats and oil are triesters of glycerol with higher aliphatic monocarboxylic acid, that is fatty acids, and in other words we can say that they are triglycerols of and commonly known as glyceride. And structure of this glyceride is shown here in this slide. So here having three ester group, COO, COO, and here third. So glyceride also called this is the general formula, and known as triglycerol or triglyceride. So this is the example and structure of this triglyceride and composition of this. And what is the fatty acids? So with only few exception, some monocarboxylic acid isolated from the fat and oil are straight chain compound containing 3 to 18 carbon atom, with the exception only carbon 3 and carbon 5 of the acid. All other acid found in the fat and oil contain even number of carbon atoms. The main fatty acid present in the oil and fats are here some examples are given. That is the lauric acid having carbon. This is the molecular formula. This is the name and the structure, and having carbon 11. Another is myristic acid having carbon 13, and then the palmitic acid having carbon 15, and next is the stearic acid having carbon 70. So they contain odd number of carbons, and the structure and formula is shown of some fatty acids. And there are so many fatty acids which show the odd number of carbon atoms. And so these fatty acids or the glyceride are of two different types, and these two types of glycerides are depending upon whether the compounds have simple or mixed group. That is, fatty acids in glyceride may be same or different, and therefore glyceride are classified as a simple or mixed glyceride according to they have same or different acid residue. And so mainly two types are there: simple and mixed glyceride. So simple glyceride is shown here in the, an example is a tripalmitic glyceride, or second name is glyceryl tripalmitate, and second is a alpha oleo beta palmito alpha dash stearin. So this is simple and this is mixed. Simple means they contain same here group, alkyl group here, and here this is the different. So here 17, 15, 17, here 15 carbons are there. So depending upon same or different glycerides, and therefore three fatty acids in glyceride may be same or different. So depending upon that glyceride, there are two types, same what is the simple and mixed glyceride. Glyceride can also be further classified into saturated and unsaturated according to their which they contain saturated fatty acid or unsaturated fatty acid residue. So this saturated and unsaturated shown here: tristyrene and this is trioline, and here this is saturated triglyceride, this is unsaturated triglyceride, and here this is solid and this is the liquid, and also showing the melting point. And here, so this is the one example of the saturated, and this is the unsaturated triglyceride. So these acids, fatty acid, can further can be classified into saturated and unsaturated. As we know that both simple and mixed glyceride are found in natural oil and fats. Oil and fats are complex mixture of mixed glyceride along with the small amount of simple glyceride. And what is the chemical difference between the fats and oil? So we can say that the main difference between the oil and fats is the proportion of saturated and unsaturated glyceride. So this is the main difference. And in case of triglyceride with higher proportion of saturated acid such as palmitic acid, stearic acid are solid at ordinary temperature, and are called fats, which are solid, which are called the fats. While on the other hand, we can say that higher proportion of unsaturated acid residue such as oleic acid, linoleic acid are liquid at ordinary temperature of 298 Kelvin, and these are known as oils. So this is the main chemical difference between the fats and oil. So in case of fats, there is a higher proportion of saturated acids, and in case of oil, there is a higher proportion of unsaturated acid residue. And examples are there of these both. So these are the different type. This is the chemical difference between oil and fats. After this, now important reaction that is known as the hydrogenation of oil is found, and here this is taking place when oil contain a higher proportion of unsaturated glyceride, add on hydrogen in the presence of finely divided nickel as a catalyst, and forming the solid fat. So oil can be converted into the fat by the in the presence of finely divided nickel and under suitable condition of temperature and pressure, and as a nickel catalyst. So the hydrogenation of oil can be, this is the traveling, this is the oil, and hydrogenation reaction with hydrogen and forming in the presence of catalyst nickel at this temperature and pressure, it is converted into tristyrene, and it is now it is solid. So this is fat. So oil can be hydrogenated and forming the fat. So in this case, this process of conversion of oil into fats is known as hydrogenation, or also known as hardening of oil. It is similar to catalytic hydrogenation of alkene and involve the reduction of double bond present in the unsaturated glyceride to form saturated glyceride. This process is extensively used for the manufacture of vanaspati ghee like dalda, rath from groundnut, peanut, sunflower and other edible oils. Hydrogenation is never carried out in completion but is stopped as soon as the fat of consistency comparable to ghee is obtained. The completely hydrogenated fat are too hard to be useful in the as a kitchen shortenings. The main advantage of hydrogenation is that as compared to oil, fats have better storage qualities and do not become rancid easily. So this is fats are easy to store and also can be stored for the long time and do not undergo the rancid. It cannot be easily rancid. So this is the process which is known as hydrogenation of oil and converting into unsaturated to the saturated compound. So after this, now we are going to see the important part of this that is called analysis of fats and oil. In case of fats and oil are extensively used in a number of industries. It is essential to check the quality of given fat or oil. This shows that this involves the determination of physical constants such as melting point, specific gravity, refractive index, like that, and chemical constants such as acid value, iodine value, saponification value, etc. like that are some important chemical constants are here. So three values we are going to discuss here. What is meant by the acid value, saponification value and iodine value. So first is the acid value. How can we define the acid value? So it can be defined as the number of milligram of the potassium hydroxide required to neutralize the free fatty acid present in 1 gram of the fat or oil. So this is a simple acid value. So it is defined as the number of milligram of the potassium hydroxide required to neutralize the free fatty acid present in 1 gram of fat or oil. So how much it is required, that is known as the acid value. The acid value is determined by dissolving a known weight of the given fat or oil in pure neutral alcohol and titrating against standard KOH solution using phenolphthalein as an indicator. So we can say that acid value is a measure of free acid present in the given fat or oil Acid value indicate that given sample of the fat or oil is quite old and has become rancid. So this can be concluded on this basis. So depending upon the acid value, whether it is rancid or not, and what is the quality can be determined by knowing the acid value by doing their titration. Second important value is the saponification value. This saponification value is defined as the number of milligram of the potassium hydroxide required to completely saponify 1 gram of the fat or oil. So similar to the acid, here also we can define saponification value, and saponification value is defined as the number of milligram of the potassium hydroxide required to complete saponify 1 gram of the fat and oil. Reaction is shown here also. In other words, we can say that it represents the amount of potassium hydroxide in milligram required to neutralize the fatty acid formed as a result of complete hydrolysis of 1 gram of the fat or oil. So saponification value is determined by refluxing the 2 gram of whey quantity of the fat or oil with the known excess of standard alcoholic potassium hydroxide solution, and then titrating the unreacted alkali against standard acid. For example, saponification value of triaurate and the tripalmetine can be determined and shown here. So this is the reaction, and here how much KOH is required is shown here in this reaction. So this is the triaurate, and this is the 3 molecular KOH, 1 molecular fat or oil react with the 3 molecules of KOH, and we get this type of potassium laurate here, and this is nothing but the soap, and this is the glycerol. So we obtain this glycerol and soap, and from this equation 1 mole of fat equals to 3 mole of KOH, and here fat having this fat have the molecular formula, molecular weight 638 gram fat equals to 3 into 56, potassium have atomic weight 56 equals to, so equals to, we can write 3 into 56 into 1000 milligram of KOH divided by this 638, then we obtain 263 milligram of KOH per gram of the fat. In this way, saponification value can be determined. Similarly, if molecular weight is given of the tribalmetine, then we also by dividing this 806, we get 208. In this way, the saponification value can be determined, and this after determining this value, the saponification value gives an idea about the molecular weight of the fat or the oil, and the smaller the saponification value, higher is the molecular weight. For example, tripalmetine molecular weight is 806, has a saponification value 208, whereas triaurate with molecular weight 638 has a saponification value 263. The saponification value also indicate the length of carbon chain of the acid moiety present in the oil or fat. The higher the saponification value, greater the percentage of short chain fatty acid in the glyceride of the oil or fat. Butter with short chain fatty acid has a saponification value between 210 to 230, whereas soybean oil has a saponification value between 189 to 195. So therefore we can say that saponification value is used to determine the adulteration of fat or an oil with some other oil or fat with lower or higher saponification value, or even by some unsaponifiable matter. So this is very useful value we can determine, and the quality of the oil or fat can be decided on this value. And the third important is a iodine value, and this iodine value can be defined as number of gram of iodine that will combine with the 100 gram of the fat or oil. So this simply it is defined as the number of gram of iodine that will combine with the 100 gram of the fat or oil. So iodine value may be determined by any one of the following two methods are there. One is a Hubble's method, and here is shown this method, that is the triaurate is converted and having molecular weight 886, and it is in the presence of AgCl2. So unreacted iodine is then determined by titrating against standard sodium thiosulfate solution using starch and indicator, and iodine value of triaurate may be calculated and shown here. So in this case, one example of triaurate is the fats and oil, and reaction is shown here. In the presence of AgCl2 we get this type of compound, and from this above equation we can say that 1 mole of oil equals to 3 mole of iodine. Here iodine 3 moles of we have taken, 1 mole of fat or oil, 3 mole of iodine, having the molecular weight 884 gram of the iodine equals to 6 into 127 gram of iodine. So atomic weight of iodine. So iodine value of iodine equals to 6 into 127 upon 884. This is the molecular weight, and into 100. So we get 86 is the iodine value of this iodine. So in this way the value can be determined. So another method is also there. So iodine value is a measure of extent of unsaturation present in the oil or fat. Higher the iodine value, more unsaturated is the oil or the fat. And for example, iodine value of linseed oil is 170, and the tung oil is the 171, soybean oil is 127, sunflower oil is 140, olive oil is 80. So this shows this value is a measure of unsaturation or extent of unsaturation present in the oil or fat. So how much saturations are there, less or more, can be decided on the basis in the fat and oil, can be decided on the basis of iodine value. So all these are the three acid value, saponification value and the iodine value are used to know the quality of oil and fats, and so this analysis of this fat and oil can be carried out in the laboratory. So today we have discussed what is the fat and oil, what is the chemical difference between the fat and oil. After that, what is the composition of fats and oil. Two types of acid and oils are there, fats and oils are there, simple and mixed glyceride, that is the acid or oil. Fat is a solid and oil is a liquid. How it can be converted from oil to fat, from liquid to solid, that is called hydrogenation of oil. And also we have discussed the analysis of this fat and oil. Three methods importance are there. One is a acid value, then the saponification value, and last is the iodine value. All these value determine the quality and all the measure of quality of the fats and oil, which it is carried out in the laboratory, and by simple calculation we can calculate the value, and on the basis of that what is the quality, whether how many unsaturation is there, that can be known by calculating the values by these three methods.